I'm like, is this real?
Now,
Is it real?
6 is different because you'll notice that 6 is an equation and it says solve. So we are going to solve this trigonometric equation. Now, we're going to solve it in radians. And we're at least going to try to do it without a calculator. I kind of got to see how it all works out. But we're going to start off with the idea we're going to solve this without a calculator. Now, this is an equation. So you're going to solve it like you solve every equation. So what might you want to do first? Some ideas. Aaron?
Multiply by sine.
Okay, so cosine cubed equals cotangent times sine. All right, I'm okay with that. So cosine cubed equals cosine over sine. That's what cotangent is. That's one of our quotient identities. Times sine over 1. So cosine cubed equals cosine.
Okay, wait. Like, obviously you can solve that, but the thing I don't understand, like, how could cosine cubed equal cosine?
Well, does 1 cubed equal 1?
Yeah, but
Are there some numbers that if you cube them, they equal themselves? Not a lot, but aren't there some? And since cosine is periodic, there'll be extras of those. Alright, so let's solve it and see. Let's see if we come up with an answer. So how would you solve that? Well, what we're going to do is subtract that cosine. Get our equation equal to 0. Don't we like to have our equations equal to 0? I mean, just like normally. Think of all your quadratics and all that. Don't you like them equal to 0? Yeah, so that's common. Now, we could factor out a cosine, and then we have cosine squared minus 1. That's something. That's something.
It equals sine squared.
Wait, equals
Cosine squared minus 1 is equivalent to 1 minus sine squared.
Negative sine.
negative sine squared.
Okay, that's
If you're going to change this, and again, I probably wouldn't, because how many functions are in my problem? 1. And if I change it, now I'm going to have 2, which is perfectly okay. It's going to solve either way. Personally, I wouldn't change it. If you're going to change it, though, it's okay to change it. There's nothing wrong with changing it. But if you're going to change it, you have to change it to the right thing. You have cosine squared minus 1, so you're going to have to bring that 1 over here, right? And then that guy's going to the other side, and he's going to be negative sine squared. So if you choose to do that, it's negative sine squared. And since that was your suggestion, I'll go ahead and do it. But at this point, you just got to think about, what do you do in normal, like 9th grade math, after in an equation? After you factor, what do? You set them equal to 0. So I could have done that here. I'm going to do it here. So cosine is 0. And negative sine squared is 0, which basically means sine is 0. Would you agree with that? Square rooting, it's going to be sine is 0. Okay, so now I got to figure out where the cosine is 0. So I'm going to look at my unit circle, because again, kids, if the cosine is 0, there's no triangle that will make that work, because you can't have a triangle with the adjacent side being 0, right? So I'm looking at my unit circle, I'm looking around at all of my quadrantal angles. So much to remember. Cosine is which letter, x or y? X. So if I want the x to be 0, then I'm looking here or here. So those angles are pi over 2 and 3 pi over 2. I'm in radians.
Couldn't it only be pi over 2 because your sine is also? Or not positive, sorry, it's 0.
Okay, this is an or. This is an or. One or the other has to be 0. So where is the sine 0? Well, the sine is 0 here or here. So that one has the answers. I'm just going to tack a line to here. Pi and 0, 0 and pi. Now I want to back up just a second. Remember I said I probably wouldn't have made this change. I would have just set that equal, said cosine squared minus 1 equals 0. So cosine squared equals 1, and cosine equals plus or minus 1. Well, look right here. The cosine is 1 here, and it's negative 1 here. So we get exactly the same answers. It's just whatever personally you feel like you want to do. But there's one more thing that doesn't happen in regular algebra, but it happens in trigonometry whenever you have functions that aren't sine and cosine, okay? First of all, actually it doesn't even matter in this case because I have a denominator. What do we know about denominators? They can't be 0. They can't be 0. So is this really even possible in this case? Can I let x be pi, for example? No, because the sine of pi is 0 and I have a 0 in the bottom. So these two answers are extraneous. Now, you also need to worry about the other functions, not sine or cosine, because don't these guys, not sine or cosine, but all the rest of them have asymptotes in their pictures? Yes. And if there's asymptotes, they're undefined, some places, and we can't have answers where they're undefined. So cotangent is undefined where? It's cosine over sine. We already took care of it. It's undefined where the sine is 0. We already took care of that one. So the answers to the question are right here. The algebra of the problem is super simple. And the trig isn't bad, there's just so much you have to remember. Yep, so the answers are pi over 2 and 3 pi over 2. All right, I got to erase. Any questions about that, Miss?
The sine of x, wait, I'm confused how you got.
How got what?
How did you get pi over 2?
I can't hear her. How I got what?
Pi over 2 and 3 pi over 2.
That's where the cosine is 0. Cosine is 0. Huh?
What about the sine of it?
Okay, remember, Tess, when you solve an equation, think of when you solve an equation in algebra class. Don't you say x is 2 or x is 5? It's not 2 and 5 at the same time. It's one or the other. So either cosine x is 0 or sine x is 0. That's not an and, that's an or, right? Just like regular math, no difference. All right, let's look at the next one. This one's a little different because it says find all solutions. We'll deal with that when we get to it. I'm gonna go ahead and subtract the 1 because I have noticed that this equation appears to be quadratic. Do you see that? And when it's quadratic, I have some choices. The easiest thing for most of us is to factor it. If it factors, we could also use the quadratic formula or complete the square, but I wouldn't recommend that with these numbers, but you could. Does anybody see how this one might factor? We'll need a 2 sign and a 1 sign for sure, right? And then we'll need a 1 and a 1. I need a plus and a minus. Maybe plus here and minus here.
No.
I was gonna say
Wouldn't
that.
be your positive? Okay.
Nick has -2 plus 1.
Okay, wait. When I FOIL, doesn't this give me +2? And this gives me -1? And when I add them, I get +1? Yeah, I'm not sure where our confusion is there. We're just factoring like always. All right, what do I do after I get it factored? Same equal to 0. So sine x equals +1/2 or sine x equals -1. All right, one at a time. Where does the sine equal 1/2? Think of all the way around. Where does it equal 1/2? Certainly it could equal 1/2 in quadrant 1. Where else could the sine equal +1/2? Quadrant 2. These are going to be the same triangle. They're equal triangle. Okay. Can you tell how big this angle is right here?
30.
That's a 1 and that's a root, or that's a plane 2, not a root 2. So this is 30, isn't it? Now does it tell me? Well, it doesn't say, so I'll go ahead and do this in degrees. So what are my answers to this part of the problem? X is either 30 or, what would that one be over there in quadrant 2? 150? 180 minus 30? Now, where does the sine equal -1? Now, no triangle. Make that make sense. Think about that. Sine is opposite over hypotenuse. In order for there to be a triangle, opposite and hypotenuse would have to be the same, right? To get 1. Can that be? No. So no triangle possible. So again, I'm looking at my circle, and I'm looking around, trying to figure out where on that circle the sine is -1. Peter's pointing down here. I think he's right, because sine is which letter? Y. And y is -1 only right there. So that's 270 if I'm in degrees. Let's go ahead and change all the radians in case sometime you have to answer in radians. In radians, 30 is pi over 6. 150, which is pi minus pi over 6. Pi over 6. And then 270 is 3/2 pi. Yep. Now, you gotta take care of this deal that says find all the solutions. This is not all of them. This is all of them if I go around one time. But we know we can go around more than once. So how do we do that again? How do we reflect that again? What do we do here to get all of the answers? Plus or minus if I'm here, it will be all of these plus or minus 360n. I'm adding and subtracting revolutions to find my coterminal angles. And n is going to be some whole number, like 0, 1, 2, 3.
How do you do the whole number symbol?
Huh?
Do we need to do the whole number symbol?
It's just a W.
Oh, it's just a.
So it says n is an element of the set of whole numbers.
Couldn't you just do, could you replace like 360 with 2 pi?
I'm going to do that up here. So if I use these answers, then I have to say plus or minus 2 pi n. Because a revolution up here is 2 pi, and a revolution here is 360. So it depends totally on how you answer the question. Now, notice I'm not worried about anything being undefined in this problem for 2 reasons. First, there's no denominator. And second, the only function in the problem is sine, and sine is never undefined. Sine has no asymptotes, so I don't need to worry about any extraneous roots or any excluded values with that problem. Okay, we're gonna do one more probably, and then we'll call it a day. Can't have too much fun. I'm gonna spoil the rest of the day. I've got something to look forward to. All right, so number 8 has me back here, and again, that tells me 2 things. I'm in radians, and I'm not gonna worry about coterminals. I'm going once around. All right, here we go. We're solving. What do you think?
You could switch tangent to sine or cosine.
I could.
I divided by cosine x and then squared both sides.
Okay, wait, Sydney, why did you do that now? Tell me why you did that.
I don't know, because I don't like the square root.
Okay,
Of the two.
okay. And I don't like it either, but I would really not like it if it were the square root of my variable, so like square root sine x or something. But the fact that it's a square root of 2 especially is not concerning for me because I have those 45, 45, 90 triangles that have root 2's in them. So I'm really not gonna worry about that square root. If this had a square root on it or something, I would be very concerned about that. But since it's just that number, I'm not gonna worry about it. Now, I'm gonna use this opportunity to talk about something I heard somebody say. Somebody said, why don't we just divide both sides by tan x? Wouldn't that be convenient? The problem is, tan x is a variable. Are you allowed to divide by variables? No, because why? They might be 0. You don't know what tan x is, and you can't divide by something that could be 0. Does that make sense to you? Now, getting everything on the same side is absolutely the greatest plan ever. But you're not going to do it by division, you're going to have to do it by subtraction. Now, a few minutes ago, we had a problem where we multiplied both sides by like cosine or something. That's perfectly okay. Multiplying is okay. Dividing is not by a variable. Now, what can I do once I get this moved over? I can now factor out a tangent. And that leaves me with root 2 cosine minus 1. What do I do always after I factor? We've done this, I kind of lectured you about it. Once you get it factored, set them both equal to 0. No fancy stuff, just set them equal to 0. So tan equals 0, or root 2 cosine minus 1 equals 0, which means cosine equals 1 over root 2. Now, don't worry about rationalizing that. That's good, actually, because that tells me I've got an angle out there whose cosine is 1 over root 2. Is that convenient for me? Yeah. What angle is that that has a cosine of 1 over root 2? In radians, pi over 4. So one of your answers to this part of the equation, I started out right here because I was excited about pi over 2, or 1 over root 2. I got pi over 4. Don't go any further though. Isn't there another angle that has that cosine? Which quadrant is it located in? 4. Cosine's positive where x is positive. So that means this angle is also pi over 4, which means the big blue angle, 7 pi over 4, I heard someone say. How did we get 7 pi over 4? 2 pi minus pi over 4. Perfect. Now, tangent equals 0. Tangent, you can't make a triangle for that, because this would mean adjacent, or the opposite is 0, and you can't have a triangle with a 0. So if that's not a triangle, that's going to be my circle. And I'm going to look around the circle until I find a place where the tangent is 0. So y over x. Looks like right there and right there, I think so. So 2 more answers are 0 and pi. Remember in trigonometry, everything can be undefined except sine and cosine. So since this problem has a tangent in it, I want to make sure that I don't have anything undefined. Tangent is not undefined here, and it's certainly not undefined out here, so we're all good. These are the 4 answers of the problem. If I had solved it and gotten pi over 2 as an answer, I would have to throw it out, because the tangent's undefined.
Like with the possible rational roots, is there any way to see like how many answers?
No, that's a great question. No. So we can solve these sometimes, and this was kind of quadratic, and you ended up with 4 answers. Some of them have 3, some of them have 1. We just don't really know.
How do you know? Is it every time there's a tangent, you have to draw a circle?
No, you have to draw when you can't make a triangle, and you can't make a triangle side of 7. If this had been 2 over 1, I'd have been fine. I can make a triangle on the side of 1.
For negative triangles to make a circle?
What?
No, because the side, if I draw it over here,
No, I'm
that
just saying,
side's
like,
negative. So I can have
we
negative
say that
sides.
that is fact because we literally
Anytime you
invented
got
it. Like, it's
zeros
not 1
involved,
equals
you
1, 1
can't make a
plus 2 is
triangle.
3.
There's
No.
no sides.
You say like, it's just, yeah, like someone invented this and said this is right, and that's why it's right.